Since we're covering Chapter 17 again this week, rather than having a live chat, I thought I'd just make a recording that goes over some problem types that you'll see in your homework. And I also wanted to review a couple of slides from the chapter PowerPoint that you may have missed, which I think sort of helps a little bit with hypothesis testing. So if you think of a court of law, somebody's going to go to trial, they're convicted, or no, I'm sorry, they're accused of committing a certain crime. Remember that we always start with a presumption of innocence, and that would be like our null hypothesis. And then we collect evidence, which is what we do when we do a hypothesis test, to see if we can support the alternative. And so in this little scenario, let's say that the person was accused of robbing a bank, and they collect evidence, and they found the bank money in the person's house. They're still wearing the mask, and the getaway car is registered in the accused person's name. So the question is this enough evidence beyond a reasonable doubt that finds the person guilty of the crime? And this is where we come into the alpha level, which we'll learn about in a couple of chapters. But when we talk about p-value, is 5% small enough chance, 1%, 6.7%? What do you want as the evidence? And remember, the p-value is the probability of seeing the data that we got or looking at the evidence in the court, and given that the null in fact is true. And again, in a court of law, that would mean that the person was innocent. We start with a presumption of innocence. So a small p-value, lots of data and lots of evidence in the crime, either the null is not true or something remarkable happened. If the p-value is not small enough, we're not surprised. The data are consistent with the model. We fail to reject the null. Now also remember, when we go to court and we have a trial about a defendant, the defendant is found either guilty, where the p-value is very small, the evidence is clear, or not guilty. P-value not very small, there's not enough evidence. But remember, we don't say the defendant is innocent. We only say that we failed to reject the null. The defendant was found not guilty. So again, to summarize, we failed to reject the null if the p-value is large. Never accept the null. We reject the null if the p-value is small. And in that case, we say we can accept the alternative. We say we have evidence to support that the alternative is true. Okay, let's take a look at some problems that you might see in your homework. Which of the following is not an appropriate alternative hypothesis? Not an appropriate alternative. Remember, an alternative is going to give a direction to the hypothesis. And remember, the null is always written in the form that we see here in C. So this is actually, let me find my little pen here. Here it is. This is actually not the appropriate form for an alternative. The other three are appropriate. We could have a greater than alternative. We could have a less than. Greater than means a right tail. Less than, choice B, is a left tail. And then a not equal to is a two-tailed test. All right, let's take a look at two problems. I'm going to work these through and show you how to use Statcrunch. So a large study showed that aspirin reduced pain after oral surgery for 35% of patients. A pharmaceutical company thinks they have a drug that will be more effective than aspirin and plans to do a randomized clinical trial to test the new drug. In the clinical trial, 538 people were randomized to one of two groups. One group received aspirin and the other group received the new drug. Among the 239 people, now again, I'm going to highlight some things I think I'm probably going to need, who received the new drug, 49.1% reported reduced pain after taking the new drug following oral surgery. Does this provide evidence that the new drug is effective for more than 35%? There's something else I need, more than 35% of the people who had oral surgery. So what's the null hypothesis that the company should use? So remember, the null always has an equal sign in it. And we're talking about a population parameter here. And so where did we start at? We started at the 35%, right? Because that was what the aspirin was effective for, 35% of the people. So that's going to be my null. I'm sorry, I'm freehanding with my mouse here and it's not working out too good. And what's the alternative going to be? Now remember, in the alternative, we always have the same number and the same population parameter that we had in the null. But the question is, what kind of a relationship do we want to talk about? In this case, we wanted to know more than, so we're going to put in p greater than 0.35. So we're going to use a one proportion z-test. We want to know random and independent. Now on this one, remember, they randomly assigned the subjects to the treatment, so that's fine. So we meet this criteria. Less than 10% should be fine. Success failure, okay, we need to calculate, and I'm going to pull up my little calculator here, 35% of the 269. Let's go with the calculator here. So 0.35 times it's 239, and we get 83, 84, and then if we take 1 minus 0.35, which is 0.65, and multiply that by the 239, that's also greater than or equal to 10. So we're good to go on that one. All right, so conduct the hypothesis test using Statcrunch. Now, one thing we're going to need for Statcrunch is we need the successes. So again, I need my calculator, and I'm going to do 0.491, the given proportion, times, sorry, it was 269 people. Whoops. Times, I had the times on, 269. 132. And if I went back on my success failure, I realized I multiplied by 239 instead of 269. I'll still get greater than or equal to 10 for both expected successes and failures. Okay, so I get 132. So let's go ahead over to Statcrunch, and I've got 132 out of 269. So here's my Statcrunch, and if you remember, we use stat, proportion stats, one sample with a summary. All right, so my successes were 132 out of 269, and we're doing a hypothesis test, and we want to test if it's equal to 0.35 versus greater than 0.35. And let's just go ahead and compute. All right, so here's my output. Okay, here's my sample proportion, 0.491, which is what I got. Here's my p-value. Here's my test statistic here, 4.84. I think I asked for that in the document. Oops, wrong one. Yeah, 4.84, so it's a z, and it was equal to 4.84, which means it's more than 4 standard deviations above the middle of the sampling distribution, which was centered at 0.35. And our p-value here was less than 0.001, very, very small. So yes, it does. Okay, we have lots of evidence now from this trial that in fact this new drug is more effective than aspirin to reduce the pain. Let's go ahead back to Statcrunch and do the confidence interval. So you can just go to Options and Edit and switch over to the confidence interval. Make sure you have the right confidence level specified. So here's my confidence level. Goes from 43.1 up to 55.0, and notice that the 35% is not included in the interval, which is what I would expect when I reject the null. So I'm 95% confident that the true proportion of people who had pain reduction with this new product is between 43.1 and 55.0%. All right, let's do another problem. Lost luggage. An airline's public relations department says that the airline rarely loses passengers' luggage. It further claims that on those occasions when it is lost, 90% is recovered, I'm probably going to need that, and delivered to its owner within 24 hours. A consumer group surveyed a large number of passengers, and they found only 103 of 122 lost their luggage on that airline and were reunited within the same day. Does this cast doubt on the airline's claim? All right, so remember our steps again. The null is going to be, again, we're doing a proportion, and it's going to be what? That specified proportion of what? 0.9, 90%. Now, we want to know if this casts doubt on the airline's claim. Now, the question is, if it's casting doubt, it shouldn't be greater than, it should be less than 0.9, right? Because we were thinking that maybe not enough are getting returned. And in fact, let's calculate the p-hat from that sample data. It was 103 divided by 122. And in fact, if you notice there, it is less than 90%. So definitely this is the alternative that we want to test. Did fewer than 90% or a smaller proportion. Okay, random independent. It didn't really say it was a random sample, but I think we're going to say it's safe to assume it. Less than 10%, yes. Success failures is going to be 90% of 122. So let's get my calculator up. So 0.9 times 122, which gives me 110. And then I'm going to do 10%, times 122, which is giving me 12.2. So those are both greater than or equal to 10, so I'm good to go on success failure. What is the point estimate for the percent of people who lost luggage and were reunited? Okay, that's where I take the 103 and divide by the 122. I just had that up a minute ago. It was like 84%. So 0.844, so 84.4%. So I can go ahead and jot this in here, 84.4. All right, so we're going to use Statcrunch again to test this test here. It's going to be 103 out of 122. So let's go back over. I'll just go ahead and edit the window I have here. So I have 102 out of 132, and we're doing a hypothesis test, and we were testing that it was equal to 0.9 versus, and I want to go less than this time. Compute, and what do I get? I get, here's my point estimate. Oh, hold on a second, something's wrong there. Oh, you know what, it's 122, it's not 132. Let me edit. This was 122. There we go, that's better. So 83.6, it's not what I had over here, wait a minute. Hold on a second. 103 out of 122. Boy, I have my numbers off today. 103. Okay, let's try one more time here. 103. Get the numbers right. There we go, 84.4. Okay, here's my test statistic, negative 2.05, and my p-value is 0.02. So it's pretty small. So my test statistic was negative 2.05. If I go here, negative 2.05. Okay, and the p-value was 0.02. So does this result cast doubt on the airline's claim? I would say yeah, because there's only a 2% chance of getting what we got, 84.4% reunited within a day, if in fact the true proportion that are reunited is 90%. And then we can go ahead and do the confidence interval. And again, we can change the window here and just go and edit it and change to the confidence interval. And we're 95% confident that the true proportion is between 78% and 90.9%. So it's just touching 90% there. And the reason for that is because we did a one-sided alternative. If we switch this over to a 90%, we'll see that it doesn't include the 90% that we said, because remember 0.02 is just beyond the 0.05. So hopefully these two examples will help you as you're working on your homework and finishing up chapter 17.